Okay, good afternoon, Algebra 2 Trig Honors class. So today I would like to talk about sigma with the series, the Arithmetic Series. So let's start it with the general structure of sigma. So by the way, this one is the second part of the lecture of Chapter 8, Sequences and Series. So anytime that you see like a symbol, kind of like a capital E symbol, so with that m equals 1 all the way to the value of m. So if you see anything like that, this one, it's called sigma. So what that means is that you want to find the sum of the entire sequence. So the sequence could be arithmetic or it could be geometric, but today we want to talk about the arithmetic. So for the arithmetic sequence, so anytime they see the structure like A, let's say AI plus BI, keep that in mind. I is not an imaginary number. I is just considered like a subscript number. Okay, so that one is just considered a subscript number. Okay, so that means it's like A sub 1, A sub 2, A sub 3, so on and so forth, like the previous problem for the previous lesson. And well, what you can do here, you can always separate it in case that this one is getting kind of complicated. You can always separate it. You can find the sum of each arithmetic sequence first. You can always do it like this. Okay, so now we'll take a look at that one of the example. So for number 18, so we do have sigma m equals 1 all the way to the 20th term. So that the sequence is 10m minus 20. So that just shows the recursive pattern. So 10m minus 20. So what this one is saying that, excuse me. So what this one is saying that it's like 10 times sigma m equals 1 to the 20th term of m minus sigma m equals 1 all the way to the 20th term of 20. So what that means is that 20, you want to add 20 consecutive times. And then this one is showing that it's m equals 1. M equals 2, so you want to add 1, 2, 3, 4, 5, so on and so forth, all the way to the 20, all the way to the 20 term. Okay? I mean, there's an easy way you can find out the sum. If you just keep adding it, that would be kind of tedious. So the way to find out the sigma with the variable, with one singular variable, so the structure, it's always considered m times m plus 1 over 2. So for this part right here, we can just do it like this. So m is what, 20? So 20 times 20 plus 1 over 2. So we can find the sum of this one first. So 20 times 21, so 20 divided by 2, that's 10. So 21 times 10, then that'd be 210. So for this sum here, so 210. So 10 times 210. And then minus, so this one just adding 20 consecutive times. So then that'll be 20 times 20. So what we got here, it's 2,100 minus 400. And then once you subtract, then that'll be 1,700. So that means this one is the sum of this recursive geometric pattern, arithmetic pattern for the sigma. Okay, so now number 18, let's check that work down the bottom. Okay, so here's what we found. And now let's try to do another one similar to this one. Okay, so number 20. So again, whatever the coefficient that we have, we can always put it right in front of sigma. So this one, once you separate it, so it's 3 times 10 sigma, m equals 1, m minus 10 sigma, started with m equals 1, 7. So again, this one, that means you want to add 7, 10 consecutive times. So 7 plus 7 plus 7, so 10 consecutive times. So what that means is like 7 times 10. And then this one here, it's just like 10 times 10 plus 1. Using the formula, divided by 2 to find the sum of that m. So that means adding 1, 2, 3, 4, 5 all the way to the 10th term. And then multiply by 3. So 7 times 10, then that'll be 70. So reduce, so 2 and 10, so this one is 5. So 3 times 5, that's 15. 15 times 11, minus 70. So 15 times 11, then that'll be 165, because 15 times 10, that's 150, plus 15, so it's 165 minus 70. So eventually, this one would be considered 95. So that would be the sum of this sigma notation for number 20. Again, check the work for number 20. Yep. And now what about for number 22, 24, all the way down to the rest of this, 26 to 28. So this one, you just want to find out the sum of the arithmetic sequence. So there's one of the formula that I need to know to find out a general arithmetic series. Again, series, that means you want to find the sum of the entire sequence. So let me get some empty space here. So the new formula that I'd like to introduce, it's called the sum of the arithmetic sequence formula. Okay, let me put it right here. So sum of arithmetic series. So the way to find a sum. So this one, it's all about n over 2 times the quantity of a sub 1 plus a sub n. So let's say that you want to add those terms together, a sub 1, a sub 2, a sub 3, and then blah blah blah, all the way to a sub n. So the way to find out the sum, it's just simply by using that n over 2 times a sub 1 plus a sub n formula. So let's just do one general problem first. So let's say that we do have all the number from 1, 2, 3, 4, 5. Keep adding all the number from 1 all the way to 100. All the perfect integer here. So as you guys can see that the pattern, so we do have 1, 2, 3. And then the last 3 digit, we do have 97. The last 4 digit, 97, 98, 99, and then 100. If you try to line up the pair, so 1 plus 99, that's 100. 2 plus 98, that's 100. 3 plus 97, that's 100. So the easy way to find out the sum is to find out the number of 100 pair that you have. So totally that would be considered 50 pair. And the number in the middle, that's considered neutral, then that would be 50, or the central number. So the sum for this one is 100 times 50 plus 50. Then that would be 5,050. And for those you might be wondering, so what's the purpose of doing that? Well, this one I just wanted to show you the pattern, the way that I come up with the sum for any kind of arithmetic series. So 100 times 50 plus 50. So let's say that you take out 50. And then we do have 1 plus 100. Okay? So 1, which means that it's a sub 1. That's the first number we want to put in for this. And then 100, that would be the last number, which is a sub n. And then 50. 50 is just the quotient of n over 2. So how many terms do we have? 100 terms. Divided by 2. Okay, so n over 2. So the quotient, which is what? 50. So 100 over 2, 50, times a sub 1 plus a sub n. So that's just the summation formula for the arithmetic series. So now for this one, we're going to be using the formula to find out the sum. So a sub 1, it's negative 18. A sub n is negative 98. And it's already given, 11. So basically, we just plug in a number. So we want to find out s sub 11. So that means we want to generate all the number from the first term to the 11 terms for the sum. So we started with n over 2, so 11 over 2. A sub 1, negative 18, plus negative 98. So negative 18 plus negative 98. So then that would be considered negative 116. And then times 11 over 2. Cross cancel, so negative 11, well, negative 1 and 16 divided by 2. Then that would be considered negative 58. Okay, so negative 58 times 11. So negative 58 times 10, then that would be negative 580. And then minus 11. Negative 91. Try to do it mentally. Okay, so then that'll be the sum of this arithmetic series. Okay, so check that. Number 22. Wait, it's actually negative 638. So let's see what went wrong here. So we're looking for the sum for this arithmetic series. Okay, so we got a sub 1, a sub n, and then n equals 11. So n over 2, 11 over 2, times negative 58. Oh, sorry about that. It's negative 58. I multiplied it wrong. So let's just do it this way. Sorry. So what I did, I just split that 11 to 10 and 1. But you can just do it, simply multiplied it. So 8, so 13, so negative 638. Okay, so number 22. Yep. Okay, so now the rest of this, quite similar, so you just want to put in that to the formula. But now, let's take a look at that, the one like 26 and 28. So what happened if that a sub 1, a sub n, they're not given? Well, if you just read through the sequence here, the arithmetic sequence, so a sub 1, technically that one is given, but it's given implicitly. So that one's 12. But a sub n, it's unknown. So we need to find out a sub 17. So using that, the previous formula we talked about in part 1. So a sub n, it's always a sub 1 plus n minus 1 times the common difference. So a sub 1 here is 12. And then plus n, 17 minus 1 times the common difference. So in order to go from 12 to 16, we add 4. 16 to 20, we add 4. So common difference is 4. So find out a sub n, so a sub 17, so we do have 12 plus 16 times 4. So 12 plus 16 times 4, which is 64. And that would be considered 76. So we got a sub 1, a sub 17. So using that, the summation formula. N over 2, so 17 over 2. Times the quantity of a sub 1 plus a sub 17. So 12 plus 76. So before you divide it, so let's just put it this way, 17 over 2, because you want to find out things we can cross cancel. So 12 plus 76, which is 88. And then 2 goes into 88, 44 times. So 17 times 44. Cannot do it mentally, just show the word. Then that'll be considered 748. So that'll be the sum of this arithmetic series from a sub 1 to a sub 17. And the other one is quite similar. So a sub 1, it's given already, 25. And then a sub n, a sub 15. So that's the one you want to find out by using the arithmetic sequence formula. And then once you get that, and then put it into the summation. Okay, so now what about for the sequence that you want to put it in as a sigma notation? So this one, it's pretty basic. So 1 plus 2 plus 3 plus 4. So the increment, it's by 1. So you want to put it into the sigma. So it's a sum of m equals 1. So m, that means like first term. So we started off with m. And then you finish that at what? 6. So what that means is showing that it's 1 plus 2 plus 3 plus 4 plus 5 and then plus 6 all the way. So this one give you the initial term, this and then the upper number here, that will give you the ending term. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 with sigma. And now what about if the sequence, the pattern is not showing explicitly? So that's what we need to find out. So here it's 1, 4, 1 over 16, 1 over 64. So for this one, as you can see that it's an increment with the power. So we started with 1/4. And then the next one here, it's like 1/4 quantity square. And then the next one is 1/4 quantity to the third power. The first one you can put in 1/4 to the first power, by the way. And then the fourth one, 1/4 to the power of 4. And then 1/4 to the power of 5. So what you can do here, you can put it in as sigma. So it's 1/4 to the power of m. And where m equals 1. And then m goes all the way to 1, 2, 3, 4, 5. The fifth power, the fifth term. So that would be the 1. So it's 1/4 to the first power plus 1/4 to the second power plus 1/4 to the third power. So anytime they see that the structure, it's not given explicitly. So that means you want to find out any kind of common structure or the common trend. So what I found here, the common trend is 1/4. And now let's try the next one. So the next one, this one is 1 plus 1/2 plus 1 over 3 plus 1 over 4 plus 1 over 5. So what happens if I put it in this way? 1 plus 1, 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Everything else, just rewrite it. But the first one is consisting 1 and 1. Okay? So 1 over 1. And then what we can do here, so we can set it up as 1 over m with sigma. And where m equals 1. And then all the way to the fifth term. So that means it's just like adding 1 over 1 plus 1 over 2 plus 1 over 3. So we don't change the numerator. The only thing that we change is the denominator. Okay? And now for the rest of this, so make sure that you guys watch the other part of the video later today. Alright, so I'll see you guys next time.